Good afternoon, everyone. My name is Ira Porwal, and I'm a student of International Institute of Professional Studies (IITS TAVV). I am pursuing Masters in Technology from in the field of Information Technology, and I'm currently in sixth sem. So today we are here to see the solutions for our internal test one. So let us dive into this. So first, the very first question we have here is we have to find the time complexity, space complexity, and power complexity for the recurrence relations. So the very first we have is linear search. So first we will be seeing it for linear search. Let me just highlight it. So this is how our linear search, I'm sorry, let me highlight it. Yes, so we will be seeing the time complexity for linear search and space and power complexity for all. So let me these complexities depends on some factors. So first let us understand on what factors all the three complexities depend on or may depend on. So the time complexity may depend on various factors such as the specific inputs to the algorithms, the efficiency of the implementation, and the use of any auxiliary data structures or algorithms. In practice, the actual running time of an algorithm may also be affected by various external factors such as hardware limitations, operating system overhead, and the size of the input data. Similarly, the space complexity may also depend on other factors such as the implementation details and the specific inputs to the algorithms. In some cases, the space complexity may also be affected by the use of auxiliary data structures or temporary variables. The power complexity of an algorithm is a measure of how the algorithm's running time grows as the input size increases. So it is typically expressed in terms of the exponent in the running times big O notation. Note that the power complexities of the algorithms are not the same as their time or space complexities. The time and space complexities may have different constants or lower order terms that affect the actual running time or memory usage of the algorithm. So now let us see for linear search. Our very first algorithm is linear search, and let us see for linear search. So which it has the recurrence relation of T of n is equal to T of n minus 1 plus O of c, where O of c signifies our time complexity for this operation will be a constant time. So here this is how this is our recurrence relation, and O of c simplifies the time complexity for the recurrence relation will be a constant time. Okay, now we can now simplify the recurrence relation using substitution, and we can substitute the values of T of n minus 1, this T of n minus 1 key value using the above relation. So we will get the term T of n is equal to T of n minus 2 plus O of c, and this O of c will be copied here as O of c. So we got T of n minus 1 की जगह we have substituted this as T of n minus 1 minus 1, so it will be minus 2 plus O of c and plus O of c from the above equation. Now this O of c from previous equation we have copied it here, and in general we can simplify T of n up to T of t minus 1. So we will go and we will have O of c. So T of n is equal to T of 1, ये हमारा T of 1 बन जाएगा, plus O of c. O of c will be n times. We will have n times. So our final equation will be T of n is equal to a plus n O of c, and O of c here is a constant. ठीक है? So a plus nc. So now we can simplify a plus nc बनेगा. So now we can simplify this, and using recurrence relation we get the time complexity of linear search as O of n. So our function goes linearly. This graph representation shows that our function grows linearly with the input size. input size के साथ our function will grow linearly, and the space complexity for same will be O of 1. Now let us see the time complexities for all the equations. Like linear search, we have already find it as O of n. Now binary search, it would be O of log n factorial O of n. Tower of Hanoi, O of 2 to the power n. Binary tree traversal, O of n. Merge sort, O of n log n. क्विक सॉर्ट का जो बेस्ट केस है, सी क्विक सॉर्ट हैज़ टू केसेस, बेस्ट केस एंड वर्स्ट केस. सो फॉर बेस्ट केस वी विल हैव O of n log n, and for the worst case O of n by power 2. Strasson's matrix multiplication, O of n power log 2 base 7, and Kratt's integer multiplication, we will have O of n to the power log 2 by 3. The space complexity we have seen for linear search, we have already seen, which is O of 1. Similarly for binary search also it is O of 1. For factorial also it is O of 1. Tower of Hanoi, it is O of n. Binary tree traversal, it is O of h, where h is the height of the tree. Merge sort is O of n. The quick sort best case O of log n. Quicksort worst case O of n. Strasson's matrix multiplication, O of n power 2, and integer multiplication, O of n power log 2 by 3. The power complexities for the above, the linear search power complexity would be O of n. Binary search O of log n. Factorial O of n. Tower of Hanoi, O of 2 power n. Binary tree traversal O of n. Merge sort O of n log n. Quicksort best case O of n log n. Quicksort worst case O of n power 2. Strasson's matrix multiplication, O of n power log 2 7, and integer multiplication, O of n power log 2 3. So this is how we have find the complexities of the all. And now let us jump to our question 2, which is Tower of Hanoi. So Tower of Hanoi is basically first let me explain you the Tower of Hanoi, what actually we have to do in Tower of Hanoi, how do we solve it, what problem do we have to solve, and then we'll go to the solution for this conceptual solution for this. So Tower of Hanoi is a mathematical puzzle where we have 3 tools, A, B and C, and n number of disks. Here we have 3 tools, or we can say 3 pillars or poles, and we have n number of disks. So here in the example we have 3 number of disks, which is green, white and red. Now initially all the disks are stacked in decreasing value of diameter, that is the smallest one is placed on the top and they are on a rod A, and the largest one is at the bottommost in the rod A. सी ठीक है. सो दी ऑब्जेक्टिव ऑफ द पजल, कि हमारा ऑब्जेक्टिव क्या है टावर ऑफ हनोई को सॉल्व करने का, इज़ टू मूव द इंटायर स्टैक, ये जो हमारा ए में विच वी हैव 3 डिस्क, टू अनादर रॉड, इसको अनादर रॉड बी या सी में, हियर वी विल बी सीइंग फॉर ए टू सी another rod, we are considering C, obeying this following simple rules. तो इसके लिए rules what we have to follow is only one disk can be moved at a time. Each move consists of taking up the upper disk from one of the stacks and placing it on the top of another stack. That is, disk can only be moved if it is the uppermost disk on the stack, and no disk may be placed on the top of the smaller disk. मतलब हमें ये जैसा हमारा एक फॉर्मेट बन रहा है कि सबसे पहले बड़ा, फिर छोटा और फिर छोटा. सिमिलरली वी हैव टू ट्रांसफर दीज डिस्क्स टू अनदर पिलर विद द सेम फॉर्मेट. So how we will do this? So the idea is to use the helper node to reach the destination using recursion. So below is the pattern for this problem. So how we will do? Shift n-1 disks from A to B using C. Shift last disk from A to C, and shift n-1 disks from B to C using A. Now we have to follow these steps to solve the problem. First we have to create a function Tower of Hanoi where pass the n current number of disks jitni hai, we have 3, so we'll pass 3 from rod to rod and auxiliary rod. Auxiliary rod is helper, which is B in our case. So make a function call for n-1th disk, then print the current disk along with the from rod to rod to rod and again make a function call for n-1th disk here. So in Tower of Hanoi में what we will be doing is let me explain you with a more proper question. So we'll be creating a stack and push the initial values, and this is how we will solve. So here we have shifted in our first picture, we have shifted the smallest one, the red disk, from A to C using B. Then in second one we have shifted our second disk, which is white one, from A to B. And in third picture we can see we have shifted our first disk, which was red colored one, from C to B. In another, then we have shifted our very first rod, which is our green color, from A to C. Then we have shifted our red colored rod from B to A. Then we have shifted our white colored rod from B to C. And then from यहाँ पर हमारा सिक्स्थ पिक्चर इफ़ वी सी, वी कैन सी वी हैव ऑलमोस्ट फॉर्म्ड आर पिरामिड. बस अब हमें ए वाली में जो स्मॉलेस्ट हमारी डिस्क रखी हुई है, वी हैव टू शिफ्ट इट फ्रॉम ए टू सी. सो वी हैव शिफ्टेड इट फ्रॉम ए टू सी, एंड दैट्स हाउ आर टावर ऑफ हनोई, आइडियल टावर ऑफ हनोई, looks like in the seventh picture. So we can take the reference of this and solve it. So thank you very much for watching this video. Hope it is helpful for you.